For this section, we're going to talk about taking more derivatives. So let's look at the first example. If I have y equals the quantity of x plus 10 squared, and we have to find the derivative of this, you might think to yourself, okay, I'm going to expand this. So we have x squared plus 20x plus 100. So therefore, the derivative will be 2x plus 20. Pretty straightforward. This is just the power rule. But here's the thing. What if instead it wasn't something nice? What if I said, okay, if y is equal to x plus 10, but instead of squared, we made it to the 100th power? Do you want to expand all this 100 times? I think that would be kind of a pain in the butt. What do you think? Okay, I'm glad we agree. So guess what? There's this thing called a chain rule that helps us eliminate such a difficult problem like this. So this is what the chain rule states. If y is equal to a composition of two functions, then y prime is the derivative of the inside function times the derivative of the outside function. Oops, sorry, this should be derivative. But the thing is, we still evaluate at the original inner function. Okay, so if we take a look at our example from above, this example, do you see a composition of two functions? I see two functions. In this case, my inner function, so since I called the inner function g here, I'm going to call the inner function g here as well. So what's g of x in this problem? Well, g of x is x plus 10. What's the outside function? The outside function is x to the 100. Okay, so now let's take the derivative of this thing. Well, according to what we've written, then y prime will equal the derivative of g. The derivative of g here is 1 times the derivative of f. Well, the derivative of f is equal to 100 x to the 99. So we get 100. Well, remember, we're evaluating this at the original thing. What was the original thing? The original was x plus 10 to the 99. Okay, so let's go over this again. So the chain rule says I first have to figure out what my inner and outer functions are. And then from there, all I do is take the derivative of the inside function first, which we figured out was x plus 10. And the derivative of x plus 10 was 1. And then we take the derivative of the outside function, but evaluate the original inner. So the derivative of this would be, well, we carry this 100 out to the front. That's where we get this 100. Evaluate it at the original inner function. And then, but remember, since we're using the power rule, then this becomes 99. So the derivative of my y function above is 100 times x plus 10 to the 99. Here's the thing. A lot of books, actually all books, and everywhere you ever see this, the chain rule, it always says, what it normally says is, it says take the derivative of the outside, then multiply by the derivative of the inside. Here's the thing. For you, in this class, I always want you to first take the derivative of the inside, then take the derivative of the outside. So always derivative of the inside, then derivative of the outside. And it really doesn't matter which you do first, because since we're taking the product, and product it's commutative, like 2 times 3 is the same thing as 3 times 2. It really doesn't matter the order. But the thing is, I want you to always do derivative of the inside, then multiply it with the derivative of the outside. I have my reasons why, just stick with that, okay? Okay, so let's look at another example. I have y equals sine of x to the 5th power. Okay, so here's the thing. I see a composition of functions already. So I see an inner and I see an outer function. So you tell me, what's my inner function? my inner function would be x to the fifth. So y prime is going to equal the derivative of x to the fifth, which is 5x to the fourth, multiplied by the derivative of the outside function. What's the derivative of sine? Cosine. And I evaluate it at the original inner function. Okay. And that's it. Now let's look at the example when y equals e to the 5x plus 1. Okay, so once again, we look at the inner function. The inner function in this case will be 5x plus 1. So what's the derivative of 5x plus 1? The derivative is just 5 times the derivative of the outside function. My outside function now is e, but we know the derivative of e is itself, and we evaluate at the original inner function. So there's my solution. Okay, I just want to give you a new rule about derivative. So the derivative of a natural log of x is equal to 1 over x. So let's say if I give you y equals 1 over x to the, let's do 2x to the 5 plus x to the 4th. I want to find the derivative of this now. Okay, so what's my inside function? Hold on. I gave you the wrong example. Let's erase this example. Okay, so let's say instead I gave you ln of 2x to the 5th plus 4x to the 4th. So what's my inside function for this problem? My inside function is this stuff. So what's the derivative of this? This would be 10x to the 4th plus 4x to the 3rd. Okay, and then the derivative of my outside function? Well, my outside function is ln. So what's the derivative of ln? Well, I told you right here, the derivative of ln is 1 over x. So I'm going to multiply by 1 over the inside, which is 2x to the 5th plus x to the 4th. Looks okay, kind of, but it's not right. Can you see why? What have I forgotten in my solution? I forgot parentheses. Remember, this represents the derivative of the inside. So I must group this all together. And then the pink stuff was the derivative outside. So whenever we do problems, whenever we take the derivatives of different parts, we must have things grouped together. Okay, here's the thing. Everything that you've done so far, you've actually done the power rule. You just don't know it yet. I mean, okay, let's take a look at y equals e to the x. You know what dy dx is already, right? It's e to the x. But check this out. What is actually, if I look at this, what is actually the inner function in this function? The inner function is just x. Well, what's the derivative of just x? The derivative is 1. Okay, then what's my outside function? My outside function is e to the x. Well, what's the derivative of e to the x? It's just e to the x. And hey, that gives me exactly what we wanted from before. Similarly, if we have y equals x squared, what's the derivative of this? Well, what's my inside function? My inside function is just x itself. What's the derivative of x? 1. What's the derivative of my outside function? 2x. So therefore the derivative of x squared is just 2x. Okay, one last one. If I have y equals sine x, what's my inside function? My inside function is x, but the derivative of x is just 1. And what's the derivative of sine? Cosine. And we evaluate the original inner. Therefore, what is this? This is just cosine x. So, in conclusion, you've always done chain rule. You just haven't known it. You just didn't know it yet. So, go back and look at all the examples again, and because we'll be using this all for the rest of the year.